Read it first. So the rate of change of temperature
Mhm.
with respect to time. How we can represent this? Rate of change of temperature with respect to time. So it can be represented as dT upon d small t, where
Yeah.
t is indicating temperature, capital T, and a
Mhm.
small t is indicating your time. So the
Yeah.
dT upon of a liquid which has been boiled and then allowed to cool is given by. So we have this minus 0.5 T minus 30. We have a rate of change of temperature with respect to time. Nisa, can you
Mhm.
explain the importance of this negative sign? What is the this negative sign indicate? What is this negative sign indicating? This negative sign is indicating that your temperature is going to decrease as time is increasing.
Okay.
If your time is
Yeah.
increasing, your temperature is going to be
Decreasing.
decreased. This sign have this importance, right?
Yeah.
Where T is the temperature and T in minutes. So we have the units as well. T is in minutes and this is in degree C.
Yeah.
Now they are saying that sketch the graph for dt upon dt for t greater than 30.
Mhm.
So how we can plot this? So suppose this is your now y. This is your y function, right? This is your y function. So we have
Yeah.
to plot this y is equals to minus 0.5 times. Uh, wait. So how we can plot this? So see, this is the time axis. This is the time axis, and this is the temperature axis.
Mhm.
But we don't have to plot the temperature. We have to plot dt upon dt. So this is my y. Are you getting this? This
Yeah.
not capital T is not my y. dt upon d small t is my y. So I have to plot, I have to keep this on y axis. So now I have this y is equals to, and now see, wait, one more time. We have to adjust. See, we don't have to plot for time. We have to plot for this temperature. See, sketch the graph
Mhm.
of dt upon dt against the t. Are you getting this difference?
Kind of.
See, wait, let me explain again. See, Nisa, read your question first. What they are saying. Sketch the graph. It means we
Mhm.
should have two axes. Graph of what? Graph of dt upon dt. So ideally it
Yeah.
should come on the y-axis,
Yeah.
correct? Against against what? Against
Against T.
temperature. So you
Temperature.
should
Yeah.
come temperature, you should take this temperature on your x-axis. What's the
Oh,
problem?
okay. Yeah.
It's a very simple thing.
Yeah.
And we have to plot for this for t greater than 30.
Mhm.
So it means now see, we can modify our this equation. So this is your y, am I right? This is my y variable, correct?
Yeah.
And this temperature, this capital T is my x variable, am I right?
Yeah.
So it means I have an equation y is equals to minus 0.5 times x minus 30. Am I right, Nisa? See how I
Yeah.
have converted this given differential equation into this linear equation. So now you
Yeah.
can plot this easily.
Yeah.
How we can plot this? So we can plot this, just put x equals to 0. If
Mhm.
you put x equals to 0, okay. If you put x equals to 0, what you will get? If you put x equals to 0,
0. Then you would get. Okay. Second.
solve it. What you will get if you put y is equals to 0?
30.
How
30.
much?
30.
30. Correct. It means this is your 30. Correct. So
Mhm.
you should have like this plot, isn't it? See? But
Yeah.
this is not my final answer. I have to tell the graph only for t greater than 30. It means
Mhm.
this is not my part of answer. I have to tell
Right.
only this part, isn't it?
Yeah.
Let me check. Have you done this?
Yeah. Okay.
Why they have sketched here open circle? because your t should be greater than 30, not included 30.
Equal
Are you
to,
getting my
yeah.
point? So that's why
Yes.
we have to keep here open circle as well. The first part is clear.
Yeah.
Now sketch the graph of dt upon dt. See, this is the reverse thing now.
Mm-hmm.
This is dt upon dt against t for t greater than 30. How we can do this? So, yeah. So we have dt upon dt is given as minus 0.5 times t minus 30.
Yeah.
So what should be the dt upon dt? So if I find this dt upon dt, if I have taken the reciprocal here, so I have to
Mm-hmm.
take the reciprocal here as well.
Oh, okay. Yeah.
So minus this minus 1 over 0.5 will be minus 2. So dt upon dt will be equals to this minus 2 upon t minus 30. Am I right? See here.
Mm-hmm.
And again, the same thing you will do. Now, on your y-axis, we should have dt upon d capital T. And on the x-axis, we should have capital T because still they are saying against
Okay.
t. Is it okay
Yeah.
till here?
Yes.
Now you should be aware that, you know, if we find it symbolically, so this is your y now, right?
Mm-hmm.
And this x is your t. So ideally, I have equation y is equals to minus 2 upon x minus 30, isn't it?
Yeah.
So any idea you are getting about this graph? This is going to be a rectangular hyperbola. If you know y is equals to 1 by x graph, you know, Liza,
Mm-hmm.
y is equals to 1 by x graph. Do you know this? Y is equals to 1 by
No.
x. This is a rectangular hyperbola like this and this. You can see, you can think here.
Oh, yes, yes, yes.
You
Yeah.
know this?
Yes, yes.
Okay. So see, we have the similar nature here. Y is equals to this minus 2 upon x minus 30. You
Mm-hmm.
will get a rectangular. So how we will plot this? The matter is, okay, we are getting. So see, Raisa, this is the graph of y is equals to 1 by x. What will be the graph of
Mm-hmm.
y is equals to minus 1 by x?
Bit of, is
So
it
it,
quadrant?
yeah, so you if you see this minus is, so it will get flipped. See, this part gets flipped with respect to this, so it will here, and this part will get flipped like here. You know, they are getting this downside. How we can plot this? So we are getting some basic idea that it should be in curved manner, it should be from here to here, and rest, what we can do, we can take some of the values and just plot it smoothly. Suppose they are saying find for the t greater than 30. So what they have done, they have taken this 35 and they can calculate some of the values. They have taken this
Mm-hmm.
120 or any value and they have calculated. And then you are getting that we have to go in this manner smoothly. So they have just plotted. Otherwise, you have to use your calculator. Are you getting my
Yeah.
point? Most probably your calculator will help here. Is it okay? Are you getting with calculator, without calculator, how we can think?
Yes. Yes.
Without calculator, we are getting that, okay, it should be in this manner. We have to go in the fourth quadrant in a curved
Mm-hmm.
manner, and you will find two values, any two values, not exactly 35. You can take 31, you can take 32, 33, 35, 36, 100, 110. You will get the nature that, okay, I'm going from like this way to this way.
Yeah. 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 Okay.
Find the area of the region enclosed by the graph B. So now we have to find this region. This is very
Mm-hmm.
simple now.
Yep.
So we have to integrate. We have to
Okay.
see what they're saying. Find the area of the region enclosed by the graph B,
Mm-hmm.
x-axis, and the line t is equals to 35 to 120. Okay, so they have clarified that they are interested from 35 to 120. Give your answer to the correct two decimal places. So see,
Yeah.
Nasa, they are interested in area. not in integration. Please see.
Mm-hmm.
So, or ideally, when you integrate it, you will get a negative answer. But area cannot be negative. So we have to take the
Yeah.
mod, right?
Right.
And this function is
Yes.
what? This function is basically, I am thinking this as y is equals to minus 2 times upon x minus 30. Isn't it?
Mm-hmm.
This is my
Yeah.
function. I'm considering in this x and y variable in back of my mind so that we can think smoothly. So if we have to integrate this, why not we can integrate? Just take the
Yep.
strip. So we will write this very simple. See, why they have taken
Mm-hmm.
this minus already? In place of mod, they have taken this minus. And the limit
Right.
35 to 120, your f of x. See, but one more thing, in terms of writing, what you have to care,
Yeah.
either, see, both the ways are correct. Either you just explain in the beginning that I am taking this dt upon dt as y and this t as my x as a variable. Are you getting? Then you
Mm-hmm.
can work on x and y as well. Otherwise, you have to follow their notation that I'm
Okay.
getting this. They are writing in terms
Yeah.
of dt, t. Both the things are same. So my suggestion is if you are comfortable in x and y and it is necessary for our solving, this is the
Mm-hmm.
necessary for our initialization of solution that we are thinking in this manner that this is my x, this is my y, this is something, something, something. So why not we should
Yeah.
explain it in writing that, okay, I'm taking this as my y, a new variable, and this t is my x. So I'm getting this function, y is equals to minus 2 upon x minus 30. Just explain it.
Okay.
And then, and then you will write in your style. No one can stop. So you will
Yeah.
write that, okay, I should take the mod from the integration 35 to 120 f of x. F of x is what? Minus 2 over x minus 30 and this
Mm-hmm.
dx. Are you getting? But
Yeah.
at the end, you should write your statement that, okay, my area is this. Are you getting this, Nigel? Otherwise, you
Yes.
have to write in terms of dt. Without explanation, if you write this y and x, someone object that what is
Okay.
this? I'm not getting. From where you're
Yeah.
getting y and x? So you have to
Okay.
be, aware of
Specific.
these things. Just matter of declaration that I'm considering this and this like this.
Yeah.
You can find it. Any problem? No problem.
No. No.
What does this area represent? What does this area represent? So see, Niza, you don't have the physics, right? In
No.
your subject. Okay, no problem. In your earlier classes, I think you must have physics, right? In your beginner,
Yeah.
in your junior classes. So see, neither, suppose, and this is now in your syllabus. So suppose, neither, we have a graph for velocity time graph. Have you heard this word velocity?
Yes.
Yes, very nice. So suppose we have a graph of velocity time graph, and someone is asking its area, the area of velocity time graph will give us what? Will it give us any spatial physical quantity? Suppose I am considering this area. This is the
Mm-hmm.
area of velocity time graph. So what does this
Mm-hmm.
area represent? Do you have any idea?
Mm, no.
No idea. Very simple. Very simple. Why I'm taking this as your example? Because you already gone through these things. So I'm just reviving
Mm-hmm.
and correlating everything, right? So suppose we have taken this strip, right? Nice.
Yeah.
So what will be the area of this strip? What will be the dimension wise, unit wise? So area will be L into B, right? In one side, you will take this area. Am I right? You will take this area in this length.
Yeah.
So what will be the unit of this length? This will give you the velocity, isn't it? This will give you the
Yeah.
velocity in meter per second, right? So unit
Yes.
wise, it will be meter per second into. This is what? This is the interval. This is the time, isn't it? This is the
Yeah.
time. So you will get the time as a second. So when you multiply it, what are you getting? Meter. Meter is what? Just like a distance or displacement.
Yeah.
So it is the displacement which we get. Are you getting how we can remember, how we can think?
Yes. Okay.
Similarly, wait. Similarly, this is the link of differentiation as well. Suppose, Nisa, we have the same velocity time graph, and suppose someone is saying this is the velocity time graph, and suppose someone is saying what will the slope of this graph represent? What will be
Mm-hmm.
the slope representing this graph? So slope is what, Nisa? Slope is change in y upon change in x. Am I right?
Yep.
Do you
Which
know
is
this change in y upon change in x? So what is
yep.
on your y-axis? On my y-axis, I have velocity, isn't it? So this is the
Yep.
change in velocity upon what is on your x-axis? This is your time. So
Time.
this is change in velocity and with respect to change in y, change in time. This is what? This is your acceleration. Are you getting my point? So
Yep.
in this manner, with the help of unit or with the help of basic definition, velocity is meter per second and time is
Mm-hmm.
again second. So we are getting meter per second square, which is the unit of acceleration. Are you getting this, Nisa?
Yep. Yep.
So think here now. I want to find what the area is representing. So area will be, see, whatever the shape of the region, I'm not interested in that shape. I'm interested in this small strip. So area will be
Mm-hmm.
length into breadth. So in terms of length, in this dimension, what you will get? You will get this dimension. What should be the unit of this dimension? This is dt upon dt. It means this is
Yep.
nothing but second upon degree C. Am I right? See, this
Yep.
is second upon degree C into on this x-axis. What you are getting? This is the temperature. On your
Mm-hmm.
x-axis, this is the degree C. Am I right?
Yep.
So if you multiply this degree C will cancel out. So how much? What you are getting? This is getting second. It means this area is giving you the time to change the
Yeah.
temperature from 30 from 120 to 35.
Mm-hmm.
Let me see. Area represents the time taken to the liquid for the cooling from 120 to 35. Are you getting this, Niza? How we
Yeah.
have
Yeah.
fundamentally correlated all these things, how you have to
Mm-hmm.
think. You don't have to remember anything. They can ask anything. So you have to
Yeah.
be fundamentally strong that you can think. Correct. So 11J now also is clear for your homework. You have to go for this. 11K is already cut from our syllabus. So let us see the first part of the syllabus.